Okay, so welcome back. And in today's topic, we will discuss a module called as diode. And in particular, we will discuss what is an ideal diode, how it behaves. In that category, we will talk about the IV curve of this diode. Then we will talk about the concept of open circuit and the short circuit with respect to the ideal diode. Then we will talk about what is forward resistance and the reverse resistance. And finally, we will also discuss what is forward bias and reverse bias. So these are the four important concepts that we will talk for the ideal in terms of the ideal diode actually. So how we go forward, you see that this is a symbol of a diode, and we will see in a moment why we are calling it as a ideal diode. So here is your pin anode, here is a pin cathode, A and K. The diode symbol as shown, and the direction of the current is from anode to the cathode, and that current is called as diode current ID. And this happens when you have a positive voltage applied to the anode with respect to negative voltage applied at the cathode, and that voltage across anode and cathode is called as diode voltage across diode, or diode voltage, labeled as VD. So why we call it as a diode, that concept could be understood from the IV curve of these diodes. So you see that we have got y-axis, that is right over here, and this is ID, that is the diode current, and you have got x-axis that represents diode voltage VD. And this is positive voltage VD, and on this other side of this x-axis you have negative voltage VD. Similarly, for the y-axis, on the downside you have negative current ID, and on the upside you have positive current ID. Now you see that you start from the zero, and at the zero voltage VD right over here, you have a sharp current, a finite amount of current that is shown by this thick red line. And at this 0 point again, if you see this axis, you have got increasing negative voltage, that is VD. However, the current on the y-axis is always zero. So how we do that and how we understand it is like this. So if you see in this quadrant, that is this quadrant, this is quadrant number one, you have anode and cathode, and your diode conducts a current in the direction from anode to cathode labeled as ID, and that current is shown right over here with this dark red line. For that, the voltage across the diode in this case is zero. So here the drop across the ideal diode is VD, which is zero, and that's why we call it as ideal diode. Ideal diode has a 0 volts of forward voltage drop, and this kind of conduction we call it as forward conduction. On the other side, in this quadrant, if you see that, you see again this is your 0 point, zero current or zero voltage. So what you see here, you have got the anode and the cathode terminals of the diode, and the current still flows from cathode to anode. So this is kind of reverse current that flows in your diode actually. And here you see there is this red line that shows you increase the voltage in the negative direction. This is the negative VD that is applied across the diode. This is positive sign here. Let me write, this is your positive sign and this is your negative sign. So you've got this VD applied here, and the current is flowing from cathode to the anode. And that is how the current is, however, on the axis is shown to be zero, ideally. So how is that possible? When you say the current shown on the axis ideally is zero, but you are showing with the help of the arrow here that there is a current flow through the diode. So we would see this current is the reverse leakage current. So it's usually much smaller than the current that flows when the diode conducts current in the forward direction. Okay, so ideally you would see that these keep on increasing the voltage in the negative direction, but the current is always zero. But in practical diode, there is a very minute amount of current that flows, and that's why we have shown that with the arrow. Okay, and let us move to the third concept here, that is the forward and reverse resistance. So we come back to this quadrant again when our diode is conducting current from anode to cathode as shown by this direction of the arrow. There is a concept called as forward resistance. When we talk about resistance, it is simply an Ohm's law, R equal to voltage divided by the current. So voltage here is nothing but a 0 volts. That is the ideal diode voltage across the ideal diode, and the current is this line that we have drawn. So the current has a value, but the voltage is 0. That is why 0 divided by ID, forward resistance in ideal diode, is always 0 ohm. On the other side, we talk about the reverse resistance. That means we are referring to this particular case where you keep on increasing the voltage in the negative direction, but the current is always zero. So again, we apply Ohm's law. Resistance is equal to voltage divided by current, and it is the ratio of VD over ID. In this case, VD is some negative value, let's say minus 2 volt, minus 3 volt, minus 10 volt, whatever. However, if you see that on the y-axis, the current is zero right here, right? The voltage is negative, but the voltage current is zero. That's why VD over zero, you have infinity ohm of your current resistance in the reverse. That is called as reverse resistance. And the concept of open and short circuit is like that. So you see that this is called as short switch, where you have the switch closed from when the current conduction happens here, and here you would say the switch is open. Actually, your switch is open because there is no current flowing except the reverse leakage current. So ideally we would see there is zero current flowing here. So this case is called as short circuit. This case is called as open circuit. Similarly, this case is referred to as forward bias. This case is referred to as reverse bias. We call it as a forward bias because we are applying a positive voltage across the diode. We call this as a reverse bias because we are applying a negative voltages across the diode. So hope you found this module quite useful. Understanding ideal diode, its IV curve, and concept of open and short circuit, concept of forward and reverse resistance, and you also understood what is forward and reverse bias. So if you like this module, share it with others for a wider reach, and stay tuned for more informative content like this. Till then, wish you very happy learning.